Hello everyone. Let us continue topic 2, mechanics. Projectile motion. Projectile is an object that has been given an initial velocity by some sort of short-lived force and then moves through the air under the influence of gravity. Baseball, stones, or bullets are all example of projectile executing projectile motion. You know that all objects moving through air feel an air resistance. Analyzing projectile motion, regardless of air resistance, the vertical and horizontal component of velocity of an object in the projectile motion are independent. Constant speed in x direction, slowing down in upward direction, and speeding up in downward direction. Acceleration in x component equals to 0. Since we choose upward as a positive reference, acceleration due to gravity always downward, so it's minus g. The trajectory of projectile in absence of air is parabolic. If there is air resistance, it is proportional to the square of the velocity. And thus, when the ball moves fast, its deceleration is greater than when it moves slow. There's the two things we need to pay attention. Peak to left of original one. And pre-peak distance more than post-peak distance. The blue section is longer than red section. Now we appropriately modify the above to meet our new requirement of simultaneous equations. Displacement formula. Let us write down x component and y component. Velocity formula. We write it down the x component and y component. Shows that the reduced equation for projectile motions are the acceleration in x component is 0, then this 2 equation. The second equation indicates that velocity in x component is constant. Since we choose upward as positive reference, acceleration due to gravity is always downward. So acceleration in y component equals to minus g. Then we get the following two equations. Use the reduced equation above to prove that projectile motion is parabolic in nature. Equation 1, from here t equals to x over ux. Equation 2, we have delta y equals to uy t minus 1 over 2 gt squared. Let's plug into t in this equation. Y equals to uy x over ux minus 1 over 2 g times x over ux squared, and y equals to uy over ux times x minus g over 2 times ux squared times x squared. If a equals to uy over ux and b equals to g over 2 times ux squared, then we have y equals to a times x minus b times x squared, and that is upside down parabola. A cannon fires a projectile with a muzzle velocity of 56 meters per second at an angle of inclination of 15 degrees. What are initial velocity in x component and initial velocity in y component. Initial velocity 56 meter per second. Make a velocity triangle. Angle is 15 degree. Ux and Uy. X component is adjacent, so that is cosine theta equals to Ux over U. That gives us Ux equals to U times cosine theta. Ux is 56 times cosine 15 degree. So that gives us 54 meter per second. Y component is opposite. That is sine theta, which is equals to Uy over U. And Uy equals to U times sine theta, which equals to 56 times sine 15 degree. That gives us 15 meter per second. So let us summarize. Ux is adjacent, so U times cosine theta. And Uy is opposite, so U times sine theta. X component is 56 times cosine 15 degree. That gives us 54 meter per second. Y component is opposite, so 56 times sine 15 degree, and Uy equals to 15 meter per second. A cannon fires a projectile with a muzzle velocity of 56 meter per second at an angle of inclination of 15 degree. B. What is the tailored equation of motion? C. When will the ball reach its maximum height? For B, we just substitute initial velocity horizontal component 54 and initial velocity in vertical component 15 into reduced equation of projectile motion. C. When will the ball reach its maximum height? Okay, let's write it down. The velocity formula V equals to U plus AT. Let's write it down. Y component Vy equals to Uy minus GT, as the upward is positive reference and acceleration due to gravity is downward. At the highest point, the cannonball traveling horizontally. So vertical component of velocity is 0. And initial velocity in y component is 15 minus 9.81 t, and t equals to 1.53 second. And t is from here to here, halfway. How far from the muzzle will the ball be when it reaches the height of the muzzle at the end of its trajectory? It's a question asking the range Sx. T up is equals to 1.53 second, which is equals to t down. Time taken is 2 times 1.53 second. That gives us 3.06 second. We are looking for range. S equals to ut plus 1 over 2 at squared. Let's write it down. X component. Sx equals to uxt plus 1 over 2 axt squared. Acceleration in x component equals to 0. So Sx equals to uxt. And initial velocity in x component is 54. Time taken is 3.06 and 160 meter. So the range Sx equal to 160 meter. Sketch the following graph. Acceleration versus time graph. Acceleration in x component equals to 0. And we choose upward as a positive reference. Acceleration in y component minus g, which is equals to minus 9.81 meter per second. And our graph is going to be minus 9.81. Velocity in x component versus time. Let's write it down. The formula V equals to U plus AT. Let's write it down. X component. Acceleration in x component equals to 0. So that gives us Vx equal to Ux, which is equals to initial velocity in x component is 54. So our graph is going to be velocity in x component is constant. And the value is 54. Let's write it down. The velocity formula v equals to u plus at. Let's write it down. Y component vy equals to uy plus ayt. Since we choose upward positive, acceleration due to gravity is downward. So vy equals to uy minus gt. Let's plug in the values. Initial velocity in y component is 15 and g is 9.81 t. Let's plot graph. Initial velocity in y component is 15. We need to find time here. So when the maximum height, velocity in y component equals to 0, that's 15 minus 9.81 t, and the t gives us 1.53 second, and this point is 1.53. So let's summarize. Only acceleration in g is in the y direction, so that's minus 9.8. Velocity in x component is constant, therefore it does not change over time. 34. Velocity in y component equals to 15 minus gt. It's a linear with a negative gradient, and the gradient equals to 9.81, and it crosses the time axis at 1.53 second. Just like that. Which one of the following is a true statement concerning the vertical component of the velocity and acceleration of a projectile when it is at its maximum height? The acceleration is always g for projectile motion, since it's caused by Earth and its field. At the maximum height, the projectile switches from upward to downward motion. So velocity in y component equals to 0. Correct answer is D. A stone is thrown at an angle to horizontal, ignoring air resistance. Horizontal component of initial velocity of the stone determines the value of. The flight time is limited by the y motion. The maximum height is limited by the y motion as well. We can actually prove this in mathematically as well. S equals to ut plus 1 over 2 at squared. Let's write it down, x component. Sx equals to uxt plus 1 over 2 axt squared. Acceleration in x component equals to 0, which means sx equal to uxt. So the horizontal component of initial velocity of the stone determines the value of sx. The initial horizontal velocity of the stone is 18 meters per second, and air resistance may be assumed to be negligible. State the value for the horizontal and for vertical acceleration of the stone. Horizontal acceleration in projectile motion equals to 0. Vertical acceleration, since we choose upward as a positive reference, acceleration due to gravity in y component equals to minus g. So that is ay equals to minus g, which is minus 9.81 meter per second. Determines the time taken for the stone to reach sea level. Fall time limited by y equation. So if we write it down, displacement equation, S equals to ut plus 1 over 2 at squared. We choose upward as a positive reference. Acceleration due to gravity in y component equals to minus g. Sy equals to uyt minus 1 over 2 gt squared. Since we choose upward as a positive reference, the downward displacement becomes negative. So minus 33 equals to initial velocity in y component equals to 0, as the object is traveling horizontally initially. So 0 times t minus 1 over 2 times 9.81 t squared. If we solve this, t equals to 2.6 seconds. Calculate the distance of the stone from the base of the cliff when it reaches sea level. The question asking the range. So let's write it down, the formula. S equals to ut plus 1 over 2 at squared. It's on data class. Write it down x component. Acceleration in x component equals to 0. X equals to uxt. So 18 times time taken is 2.6 seconds. That gives us 47 meter. Calculate the angles that velocity make with the surface of the sea. So the question is asking this angle, which is equals to this angle. Since final velocity has an x component and y component, we need to find x and y component first. Let's write it down. Velocity equation: v equals to u plus at, and x components. As acceleration in x component equals to 0, this is going to be vx equal to ux. Initial velocity in x component is 18 meter per second. So the velocity in x component is 18 meter per second. And let's write it down, the y component. Vy equals to uy plus, since we choose upward positive, acceleration due to gravity in y component is minus gt. So that is going to be Vy equals to Uy minus Gt. Initially, the stone is moving horizontally. Initial velocity in y component equals to 0. So that gives us minus Gt. And that is going to be Vy equals to minus acceleration due to gravity 9.81. Time taken is 2.6. And that gives us minus 26. The question is asking the angle, which is tan theta equals to opposite Vy over adjacent Vx. That is theta equals to tan minus 1, y component 26, velocity in x component is 18. And that gives us 55 degree. So this is equals to 55 degree. A stone of mass 0.44 kilograms thrown horizontally from the top of cliff with a speed of 22 meters per second as shown below. Calculate the total kinetic energy of the stone at sea level, assuming air resistance is negligible. Since the air resistance is negligible, change in kinetic energy plus change in potential energy equals to 0, which gives us change in kinetic energy equals to minus change in potential energy. Potential energy equals to mass times acceleration due to gravity times the height. Change in height equals to final height minus initial height. Initial height equals to 32 meter. Final height is 0 meter. So 0 minus 32 equals to minus 32 meter. Let's plug in. Mass is 0.44. Acceleration due to gravity is 9.81. And change in height is minus 32. That gives us 138 joule. Change in kinetic energy is equals to final kinetic energy minus initial kinetic energy, which is equals to 138 joule. And from here, final kinetic energy equals to 138 plus the initial kinetic energy. So final kinetic energy equals to 138 plus initial kinetic energy equals to 1 over 2 mass, and velocity squared equals to 138 plus 1 over 2. Mass is 0.44. Initial velocity is 22. We squared, we get 240 joule. So the total kinetic energy of the sun at the sea level is 240 joule. In practice, air resistance is not negligible. During the motion of the stone from the top of the cliff to sea level, 32% of the total energy of the stone is transferred due to air resistance. Determine the speed at which stone reach sea level. If 34% of energy is consumed, 66% remaining. 66% of 240 is 158 joule. And kinetic energy is 1 over 2 mass times velocity squared equals to 158 joule. Solving this gives us 27 meters per second. A stone is thrown with a speed v from the top of a cliff of height h as shown. The stone is thrown at an angle to horizontal so that it rises to a height h above the top of the cliff before falling into the sea. Acceleration of free fall is g. Air resistance is negligible. Which one of the following expression gives correctly the speed of the stone as it hits the sea? As the air resistance is negligible, the mechanical energy is conserved. So change in kinetic energy plus the change in potential energy is equals to 0. So we rearrange change in kinetic energy equals to minus change in potential energy. Potential energy equals to mg delta h. And change in height equals to final height minus initial height. Final height is 0. Initial height equals to h. So that is 0 minus h. Both side times 2, we get that 1. Mass cancel out. Final velocity squared equals to initial velocity squared plus 2 times gh. Both sides squared, we get the correct answer D. The ball is projected from the ground level with a speed of 28 meters per second at an angle of 30 degrees to the horizontal as shown below. There is a wall of height h at a distance of 16 meters from the point of projection of the wall. Air resistance is negligible. Calculate the initial magnitude of horizontal velocity of the ball and vertical velocity of the ball. Initial velocity equals to 28 meters per second. And angle is theta, which is 30 degrees. X component is adjacent, so that is cosine theta equals to ux over u. That gives us ux equals to u times cosine theta. U is 28 times cosine 30 degrees. That gives us 24 meters per second. 24 meters per second. Initial velocity y component, it is opposite. That is sine theta equals to uy over u. And uy equals to u times sine theta. Initial velocity is 28 times sine 30 degrees. That gives us 14 meters per second. That's correct. 14 meters per second. The ball just passed over the wall, determines the maximum height of the wall. So we need to find the height of the wall. So we utilize the formula S. S equals to ut plus 1 over 2 at squared. Let's write it down x component. Acceleration in x component equals to 0. So that is sx equal to uxt. The range is 16 meters. Initial velocity in x component is 24. We calculated in the previous slide. And t equals to 0.67 seconds. Now, let's write it down the y component of this equation. We choose upward as a positive reference. So an acceleration due to gravity is always downward. So ay equals to minus g. Sy equals to uyt minus 1 over 2 gt squared. Let's plug in. Initial velocity in y component is 14 times time taken 0.67 minus 1 over 2 times 9.81 times time 0.67 squared, and the height equals to 7.1 meters.